you should have 2 sheets, 2 note sheets. We're going to go through all of it today. It's here to help you. We're establishing basically what we need to know for next week's test. So today's the last day of new material, which that's a huge positive for us. So we're going to quickly do acid nomenclature that we were supposed to do before break, but we felt like we should kind of get a handle on what we were doing before we left for break. So acid nomenclature of the 3 is probably the least intensive, and we have some notes on that. So if you want, find the acid nomenclature sheet first. That would be the one that we're going to go off of. And then what we're going to do is we're going to combine and organize nomenclature. And the true test is, can you look at a compound or a name, a formula or name, and be able to give us the proper formula or name without being told, hey, now you're doing prefixes, now you're doing charges, now you're naming an acid. You need to be able to identify that. So today we're going to start giving you the tools to be able to do that. So first, and we're going to go through these a little quicker than last hour, but a lot of us, we have a lot of thoughts when we think of acids, and most of it's dissolving hands and faces and bones and all that stuff, and unfortunately, no matter what, we can't compete with what you're thinking. In your brain, you have it bigger and better than anything we can ever give you. But we'll give you some things that, not all these actually are acid related parts of movies, but it's kind of things that we may think about when we think about acid. So also, I always love acid danger signs, like the drop hits you and then you just lose part of your finger. That's all. That's what. That's right. So this first one's Austin Powers. It's actually ill-tempered sea bass. Not acid, but whenever we see acid in movies, what color is it always? Green. It's always green, right? It's usually bubbling, all that stuff. It's kind of funny. It's pretty much stereotypically the same every single time. So we're going to move ahead a little bit. Hello. Hang on.
Not a good time to lose one's head.
Oh, indeed.
That's not the way to get ahead in life.
No.
It's a shame he wasn't more headstrong. He'll never be the head of a major corporation.
Okay, that'll do.
Okay.
This is from The Rock. Here's another one. His hand's really getting hit. They're going to steal big missiles that have actual nerve agents in them, but it looks kind of like an acid. Oops.
Let's do it.
If you don't sign your lab safety contract. A little Jurassic Park.
You want food? Look at me. I just fell down a hill. I'm soaking wet. I don't have any food. I have no food on me. I have nothing on me. Hey, pets. Look, this stick. Here, look, this stick. Stick, stupid. That's a stick. Look at this stick. Yes. You like this stick? Oh, yeah. And no wonder you're extinct. I'm gonna run you over when I come back down.
Little Who Framed Roger Rabbit. Wrap it up a little bit though.
Goodbye, my darling. Goodbye. I think I'm gonna faint.
It's green. This is the Batman I grew up with.
Eckhart! Think about the future.
Hey, it's green. It's public. What? And finally from Alien.
Could kill him. I'm willing to take that chance. Just cut it off from there.
You take responsibility.
Yes, I'll take responsibility. I've got him out of it.
Where do you want to do this?
Making a decision just below the knuckle there. It's done by God.
That crap's gonna eat through the hull.
That thing's gonna eat through the goddamn hall. Come on! What's going on? This way.
Next deck.
There it is. Don't get under it. Don't get under it.
Looks like it's stopping.
Take a look at this, man.
Brad, give me, what do you got, a pen there? Give it to me, quick.
Come on, come on!
Don't get anything on your arm.
It stopped. Didn't say anything like that except, molecular acid.
Must be using it for blood.
It's got a wonderful defense mechanism. You don't dare kill it.
All right, so there you go. But I thought, although I can't compete with that, I'll do the best I can, and we'll do a little mini demo today on something. It's not anything even close to that, but let's see what we can do. And I'm going to double it from last hour. So I have some sugar. Oh yeah. Add a little bit of water. And then what I'm going to do is I'm going to put some sulfuric acid in here. Very strong sulfuric acid. And unfortunately, see, it's not exciting. That's what it looks like. It could be water. Well, it's a lot thicker than that. But what we're going to do is we are going to strip the water out of this. So we're going to dehydrate the sugar. Just to show you, before we go, what that looks like, is that wood is like cellulose. It's basically carbons, hydrogens, and oxygens. So there's H and O in there. So if I put this piece of wood in here, and I pull it out immediately, all that's left is the carbon. It was already dehydrated right there, like that fast. So, that being said, let's put it in the sugar. Let's see what happens. Bless you. Whoa. And there you go. And it really smells. All right, so let's learn how to name this. All right, you have a sheet. It says acid nomenclature. There's two kinds of acids that we're going to learn about today. First kind is called a binary acid. Basically has two atoms, bi means two, and then the other one more or less is going to have polyatomic ions, which has more than two atoms in it. So there's a couple of lines that you need to fill in. We tried to streamline this for you just because we don't want to get worried about and bog down in all the little minutiae of the naming of this. So first, what we always have to have is that the prefix, when you have two atoms, is always hydro. Always hydro. All right, the suffix will always end, you're going to drop the ending, and we're always going to add ic. Okay, so what's nice about this is that there's really only 4 acids that follow this rule. So if, right away, I'm just giving you a warning, most students get really hydro happy and start using hydro all the time, and that's not what we're looking for. So if you're not sure, you actually probably don't want to use the prefix hydro. So your example is HF. So if I have HF, that's 2 atoms. 2 atoms. H and then my F. So I know it's an acid because it starts with an H. So what do? I say hydro. I'm going to use the word fluorine. I drop the ending and add the word ic. So it becomes hydrofluoric, and then we say the word acid. So it's hydrofluoric acid. So that's my example that I have there, that first one for you. So I would write it down. Let's see how we'll write it. Hydrobromic. Okay. So if I go the other direction, it's not going to pop up here. But I think you can figure this out already. The minute it says hydro, it's H blank. It's just H and one other element. So what do you think this is? The formula for hydrobromic acid is H? Br. Wow. I know. There's only 4 of them. It's the halogens. So hydro, halogen. Think of it that way. Hydros and halogens. So it's HF, HCl, HBr, HI. That's it. All right. What if you don't have 2 atoms? So you have more. Now this is already written there, so highlight it, box it, whatever else. I have them on the side. There's 2 different parts to this. If a polyatomic ion, we've learned from before break that a polyatomic ion ends usually in an 8 or an ite. So if I'm using a polyatomic ion that ends in 8, it's going to go to ic. You ate something icky. That's the best way you can remember that. Because I don't know how to do that one. Ite goes to us. You're just going to have to work on that one. So I have the actual example on the bottom. So go to the bottom of your sheet here. So I have HClO2. And as we continue on, it is very smart that I'm usually working with a periodic table and a polyatomic ion sheet to help me see all this. But today, right now, I'll help you out. So this is clearly not hydrochloric acid. And why? Because I have more than 2 atoms here. So I have to look this up potentially. So if I did, and you may want to write this on the side, it's up to you, but this is going to be ClO2 minus. And I will tell you why I know it's just a minus. on the next slide or so, but there's only one H, so this has to be only a 1 charge, because H's are +1. So, that's either chlorate or chlorite, most likely. Like if I'm betting on that, it's going to be one or the other. If you look it up, that was chlorite. So ite goes to us. So there's no hydro. So literally, it just becomes chlorous acid. So that's the bottom example. The other one that I'm not going to have pop up, but we're going to go the other way, it says chloric. Okay? You're like, oh, HCl. It doesn't say hydro. So it's not just one element. So ic came from 8. So let's see if we can remember what happens. If I have an ite with that many oxygens, what does an 8 have? Does it have 3? Does it have 1 more or 1 less? 8s versus ites. Anybody remember? Has 1 more. You ate something, you get bigger, right? So chlorate, wouldn't chlorate be ClO3 minus 1? So chloric acid would simply be HClO3. So I write that in. Chloric acid is HClO3. Because an ic comes from an 8, and 8s have 1 more than an ite. So that's the top. Oh, that's the top. Yeah. All right. So, that being said, what I want to do is flip your sheet over. I know I'm wasting my time right now. I know you all did this during break many, many, many times over because you needed to memorize these by next Wednesday. So I know that you maximize your time not playing Battlefront 2 or whatever else. But just in case you don't remember, I want to help you with determining some of these polyatomic ions. You are going to be given a sheet with a lot of them. There's actually less that you have to memorize, and you're going to be given more than you have to have down. But I want to help you out. Like, look at all these that you got to know. You got to know all these names and formulas. Like, it seems impossible, yet it isn't at all. So today what we're going to do is we're going to determine every one of these formulas either by telling you, yeah, you got to memorize these, or this is how you can figure it out. And we already went through this once before. Mr. Kelleher did this for you last Wednesday, but let's review it. So this is a sheet, and it has the stars. You guys got this last class that we had. But let's take a look at our rules. I'm not even asking you to write these down. We're going to apply them, okay? If you want later, we can go back and we can do this. You have these notes already. So first, how do you figure out a charge? If your atom is from an odd group, it's going to be -1. And if it's from an even one, it's -2. We'll talk about this, but unfortunately these two don't follow that. Next then what we're going to do is we're going to figure out the number of oxygens. So if I know the charge, I can figure out the oxygens. And the easiest way to basically say it, and this applies for at least the ones you have to memorize, is that all -1s have 3 O's and all -2 has 4 O's. And which ones am I talking about? The 8s. Because I know an ite is 1 less. So this is how I remember it. -1, don't get involved with the negatives, but 1 is less than 2, so 3 is less than 4. So the 2s have 4, the 1s have 3. Like they're 1 less. So let's put this into action. So here's the list. It's the same as on your sheet. Unfortunately, right off the bat, let's get this out of the way. These two we have to have memorized. There's nothing I can say about it. I'd write them on there. I'd put a little bracket and say memorize. It shouldn't be a huge leap for phosphate, though. Like, you shouldn't be like, I don't even know how to start. You should, every time, be able to say PO and then go, okay, I don't know the charge or the number of O's. Right? It's always an element, except for ammonium, it's always an element and then O's. So phosphate, that's not a big stretch to think, well, that probably has phosphorus in it. Okay, so taking those 2 out, these other 9, we can all figure out. So I'm going to go up to chlorate right now. Anything I know about that right now? If I wanted to just start writing down, what's one thing I know about it? Cl. There's a Cl in it. In fact, there's a Cl and an O. There's a something and an O in every one of these. So how I could start is ClO. Like, if you can't get there and we say chlorate and you're like, oh, let's try nitrogen and I'm going to put some cobalt in there. Like, you are so far off. You haven't looked at this at all. Like, give yourself a fighting chance. Right. I'm applying the rules that I just put. So I suggest when I don't have many on here. When I put one of these down, I just make a little note. What group is that in? That's in group 17. And what is that? That's an odd number. So what does that mean? Odd number means -1 charge. Odd, -1. Even, -2. So then the only other rule you have to have down, which if you're looking at this, go, wow, there's a lot of rules. There's 2 rules. Odd or even charge, and then -1s, 8s have how many O's? 3. 2, negative 2's have 4. That's all I got to remember. So this is a negative 1, 8. And I will cross that bridge when we get to eights and everything else. But negative 1, 8 has a 3. If I can just practice that a little bit, you'd be amazed how you can apply that. Now, you could just do brute memorization. I think all 3 of us teachers had to just memorize it full on. But, all right, so what do I know about this one, and this one? They're all ClO minus at the beginning. Well, whoa, how do you know that? Because it's ClO, and then the Cl makes it a negative 1. My job now is to figure out how many O's I have. Right? How many O's do I have for each? So, if you can even memorize one of them, it's not a bad idea to have a little bit down what the 8's mean. Again, negative 1 8's are 3. So what's an 8 mean? 8's have 1 less, right? So shouldn't that make sense that that's a 2? So if you started with that, by the way, let's just take a step back for a second and act like we didn't have that first one. You got the negative 1 and you go, wait, okay, negative 1's, oh, I have an 8. Okay, negative 1 8's have 3. Step it down 1, go to the 2. Instead of sitting there and memorizing, okay, negative 2's have 4 for an 8 and 3 for an 8. Negative 1's have 3 for an 8 and 2 for an 8. I don't need to memorize all 4 things. Just memorize the 8's. All right, take a logical step here. If I still have an 8 here and I have a prefix, you think it's adding or taking away? It's probably going to take away. Well, how do you know that? Because if I add it, is it not just the that again? We're not going to name something twice. Hey, it's this or this. Not with this kind of naming. And anyway, hypo means that you're lacking in something. Hypoglycemic, anything like that, it means you're short. So you're losing yet another one. So actually, that's the formula. I'm done. That feels weird. That's it. Why? Because I went from 2 to 1. So any thoughts? How many O's are in this one? Perchlorate has an 8 and then a prefix in front of it. 4. I add 1, right? I'm not sitting here memorizing that per means more. I see the word 8 and there's a prefix in front of it. It's probably adding to that prefix. Okay. If I've confused you completely, hopefully I can bring you back. So here we go. Nitrates. What do I know? Nitrates and nitrite. I know for sure that it is N's and O's, right? N's and O's. So boom, N and O, N and O. No! What do I know about the charge? It is group 15, so it is negative 1. So, negative 1 8's have 3. So that's that, and the other one is a 2. What do I know about sulfate and sulfite? Sulfur, SO. Again, give yourself a fighting shot. What is S? S, I wrote this down, you might want to write it. It's group 16. That's even. So that means negative 2 for both. So then what do negative 2 8's get? 4. So the other one must be 3. So that leaves us with 1 left. And there's 2 ways to approach this, but let's first figure out what's in it. Guys, this one's actually very self-descriptive. Hydroxide. There's oxygen and hydrogen in it. Unfortunately, it's just backwards in the name. It's O and H. So there's 2 ways to do this. Again, don't even look at the O. H is what group? It's group 1, so it's odd. So the charge would be negative 1. I actually think of it as oxygen by itself would have a 2 minus charge, and hydrogen would have a plus 1 charge. So when you add those together, it ends with a negative 1. But you know what? Shouldn't even said that out loud. It follows with what we're doing. So, trying to show you that it's not about memorizing them all. You can. I think note cards are a really good idea. Little flashcards, little ones. You just go through them every once in a while. But give yourself a fighting shot. Put the letter down, whatever symbol it starts with, put that O, and then your job is to start figuring out the charge and the number of O's. It's very manageable. Okay. In the lower right of that page, quickly, we're just going to fly through this. This is not, or in the bottom, middle, bottom, or lower right, wherever you have room. I just have 2 examples. I'm not even writing any notes. If I say hydrated, I hope you all think of water, right? I'm hydrated, I'm dehydrated. That's not a big stretch. There are compounds that have water attached to them naturally, okay? And we can strip them off, we can add them. We're going to do a lab next chapter called the hydrate lab, or a labette. And if you ever, in beef jerky or clothing, or ever you get these little desiccates, those little grainy packets, you know what those, they keep moisture out. Those things have had their hydrates, their water stripped away, and then they slowly gain water back. So they help keep whatever item you have as dry as possible, more or less. So, let me show you something else. Just write that example down. I'm just doing 2 examples. See this dot? What this is, I'm not even worried about the front part right now. This cobalt chloride compound has 6 waters attached to it. So if I had 2 of these things, I'd have 12 waters. If I had 3 of these, I'd have 18 waters attached total. So the dot is not a multiplication sign. The dot literally means with. Like cobalt chloride with 6 waters. Well, how do we do it? You say a prefix, and then you say the word hydrate. What's the prefix for 6? Hex, maybe. So it'd be hexahydrate. Now what we got to name it all. So little review, quickly. That's a metal. So every time I see a metal, I take a breath and go, is that in the middle? Does it need a transition metal? Roman numeral, I mean. It's a transition metal, so yes. So the name of this is cobalt-3. We'll get all back to this week. But cobalt-3, you do reverse cross. Cobalt-3 chloride, and then here's the part that I just want to show you. Hydrates really should not pose a challenge to you, though. You just say the prefix, and then you say the word hydrate. So, what I'd like you to try to do, on your sheet you already have the nitrate. I'll even give you a huge boost. Here's barium, and it's a 2+, it's in the second column. See what you can do. Can you quickly come up with this formula? Do what you can. So you say this first part, you write the formula, and then you put a dot, and then you put how many waters you have. So, because I don't want to get bogged down with this right now. We have Ba, and then NO3 minus and Ba2+, so the 2 comes down. So whenever you bring a number down to polyatomic ion, as a little review, you got to put a parenthesis. So you should have Ba, parenthesis, NO3, and then a 2, dot, what? What do I have at the end? What's tetra? 4? Yeah, 4. So it should look like that. So, just understand though, it's not like we're reinventing anything. If it ever says the word hydrate and has a prefix, just dot and then how many waters you have, okay? Everything else, we're not changing naming schemes. So speaking of naming schemes, once you're done with that, go to your other sheet, please. What we are doing today, we are setting the table. We are not teaching anything new for an entire week. So by the time we get in here next week, Wednesday, we are taking a test where we give you the formula, you give us the name. We give you the name, you have to give us the formula. And we are giving you the foundation to be able to do that starting today. And it's basically now up to you for practice. We know exactly, it's been proven scientifically how many problems you need to practice on, and we will provide that number of problems for you throughout this week and beginning of next week. Covalent ionic acids. Please understand, I'm streamlining this. We could do tons of notes. Okay, this situation, this situation, this situation. I'm just trying to give some general ideas. So, here are your first thoughts. If it's covalent, you probably see prefixes. This is where we're writing. So that means you do not cross. Right? Either you're crossing charges or you're using prefixes. Don't start crossing prefixes. And the other thing that's going to be a huge hint, if it's a formula, it's going to be a non-metal, non-metal. That means they're both on the right side of the periodic table. Okay? So, what are the rules? The general rules. There's not a lot. It's not like we were writing a lot on each of these. But what do? Reminder, you do full name, prefix if there's more than one atom. And again, this is your choice. We're trying to give you kind of an overall snapshot, which should be kind of nice for you. But these rules have actually been given to you before, just not all together at the same time. Second one's adenide, and you always have a prefix. And that's it. Covalent compounds, if you can just realize, hey, it starts with a non-metal, prefixes. Those work pretty well. Ionic, unfortunately, has a couple more rules, but it follows the same kind of suit. So first thoughts. First, they're charges. So you do crisscross. That's the big difference. We're doing prefixes or we're doing charges. And how I know that is because it starts with a metal. And then the other one would be a non-metal. Again, there's more things we could write. These are just some ideas, some thoughts. So, what are my general rules? Again, full name, Roman numeral if it's a transition metal. It's a big deal. Second one, you add ID. With a polyatomic ion, just a nice little reminder for you, you always use parentheses when you cross. I feel like that's something that should be said again. So when you're using polyatomic ion, when crossing you use a parenthesis. Just a good thought. And then acids. Final thing. Starts with an H. That's how you know it's an acid. It starts with an H and the acid in the name. That's it. Like, that's why you would know. It's about the easiest thing you can say, oh, that's an acid. It starts with an H. Sweet. And we just learned the two rules. If it's two atoms, it's H blank or hydroblankic. Right? It's either H in one atom. By the way, that's only 4 of them. It's going to be F, Cl, Br, or I. That's it. And then final thing, then we're going to do 5 examples and I'm done. 3 or more atoms, you're going to use a polyatomic ion. 8 goes to ick, 8 goes to us. And then we're going to learn today, we're going to see them, that your H is equal to your negative charge. And that's it. And believe me, we don't expect you to have it down yet. The 5 examples on the back, it's going to start helping you a lot. So, as we're finishing this up, please understand, the whole goal of this, it's important to know your goals. You need to be able to take a formula and give me a name, or take a name and give us a formula. So on the back side of this sheet, we have both ways. Obviously the answer is already given to you, but what I am going to give you today is how would you be able to get to that answer. So we're going to go one direction, and then we're going to come back the other way. How would you be able to go from formula, from name to formula, and then from formula to name? How would you be able to do that? What are the things that you see? Okay? I'll give you about 30 more seconds to get this down, or else I'm going to have to get it by name. Mr. Blackford, at some point, could you just run to the back of my room and grab in the final cabinet, like a little 50 mil? Oh. All right, here we go. So, how do I go knowing that this is CS2? This is about the best thing I could give you. Thinking about, because this is, like, I give this to you on a test, you have to be able to give me this. Okay, so what's the big signs that I see? I see prefixes, right? Now, this isn't everything. I mean, again, I could make a huge paragraph about each one, but we're just trying to hit the big targets. So I know that's covalent. Why is that a big deal? Because I don't cross. What happens is you guys all of a sudden take the die, yep, cross it. You don't cross prefixes, you crisscross charges. And that's how I would get there then. Oh, okay, fine, it's 1 C and 2 S's. Done. That's my answer. And I love it when we do a note sheet like this and then you're like, oh, I know the answer. It's like, yes, you do. It's right there. That's not the point of this. How do I get back here? How would you know that it's carbon disulfide and not carbon sulfide? Here's the way. It starts with a non-metal. That is the most important thing you could see if you're going in this direction. How do I know it's a non-metal? If you guys don't know, look up here for a second, stop writing. Basically, just take a 45-degree angle right here at aluminum and just go straight down. Anything to the left here, for surely, is a metal. Okay? More or less. There's other ways to know about it, but there's a little triangle right here, starting at carbon, phosphorus, selenium, iodine. That little triangle is non-metals. So, what do? I use prefixes. That's how you would know to use prefixes. And that's what this back sheet's all about. It's showing you how to get from one way or the other. And I'm going to go through all of them. In that back right, there's like a little 50s. But I'm just afraid it's still not going to shoot out enough. That'd be awesome. Thank you. All right, next one. Calcium chloride. How do I know it's CaCl2? First off, I don't see prefixes. So that's why I'm dealing with charges. And what do we do with charges? We crisscross. Makes you want to jump. So not all of you have seen it. If I go back the other way, how do you know not to use a prefix? Well, what is the last one? What do we do? How did I know I was going to use a prefix? Because it started with a non-metal, right? This way, what does this start with? It starts with a metal. And if you don't want to write the whole thing, it starts with a metal. Right? Calcium's way over here. If it starts with a metal, no prefixes. So instead of saying calcium dichloride, it's just calcium chloride. These are the things you have to practice and get down. This is, well, how do I know? I'm showing you how you know, right here. This is how you know. Does it start with a metal? Does it start with a non-metal? Non-metal, prefix. Metal, no prefix. It just takes practice. Believe me, we know the exact amount of problems that you need to practice this to become good at it. So that's how you do that one. 3 more, and the last 2 go really fast. We're doing well. And we'll try to do the demo again. You get a double demo. Double demo Wednesday. Here we go, nickel 3 nitrate. To me, there's a lot of stuff going on here of why I know what's happening. But one, I see the word 8. The word 8, polyatomic ion. So when I say ion, I'm thinking crisscrossing, right? If I say the word ion. I did not write this, but I suggest you doing this. I'll let you finish writing this first. What does that parenthesis mean? Is it the number of nickel or the charge of nickel? Charge. I would make a little arrow and just write charge somewhere, like just off of that. I don't have that up. You need to, that's easier. Anybody ever looking at a Roman numeral going, oh no, you're thinking of it the wrong way. That's less work. Look at it. Yes, you are. Yes, you are. If I go back the other way, how do I know it's nickel 2 nitrate? First off, big deal. That's a transition metal. So I needed a Roman numeral. And then the other part, parentheses. That's a big hint to me. There's a bunch of hints. Again, there's more than just that we could write. But that's just one idea that you could be thinking about. Okay, 2 left? 2 left. All right, acids, obviously when it says the word acid, it's not like, I wonder. So in this one, why do I know it's only HCl? Big deal, hydro. Hydro means it's just H and something else. Like that's all I would even write. It's just hydroblankic. Sorry, I'm going the wrong way here. That means it's H and then just that element. That's it. So like hydrochloric acid, I'm sure you've all heard of it. If you haven't, that's in your stomach. Heartburn is actually when the acid's coming up and it's kind of sitting around in your area that is close to your heart, so it feels like your heart is aching. But it's just acid. Coming the other way, how do I know it's hydrochloric acid? Because it's only 2. What's weird is the simpler acid actually has the longer name. I think that's what's confusing to students. So hydro plus ick, that's it. Hydro blank ick, that's it. There's nothing else to it. I'm not saying blank ick, blank it, blank ick. So the final one, how would I know to do that? And I know that's an example that we had, but this is what you could mentally be thinking about. Chloric acid, how do I know that it's not HCl and HClO3? Because there's no hydro. So the minute I say no hydro, that's got to be a polyatomic ion. So in this case, there was an ick. So that came from 8. So no matter what, even if you don't know what chlorate was, you know that it's chlorate. Because chloric has to be chlorate. And there are good guesses and bad, you guys. You should know that it's ClO something, right? I mean, worst case scenario, ClO and take a shot. But all of a sudden we see like P and N and like you're making up letters. ClO something. Whatever it is, that element O something, if you're totally struggling with it. If I come back the other way, how do I know it's just chloric acid? Because there's multiple atoms, so there's no hydro. And then again, I remember that 8 goes to ick. I had to maybe know that that was chlorate. If it was chlorite, it would be us. It would be chlorus. So let's take a look at some examples. On your nomenclature 3, which is your acids, we have either names to formulas or formulas to names. So taking a look at number 3 for a moment. When we see acetic, although that looks very foreign, it's not as complicated as it might look. If you simply look at your polyatomic ion sheet, which supplies polyatomic ions that do not need to be memorized, acetic, ick comes from 8, so this is acetate. And acetate is simply C2H3O2 minus 1. So by that being given to us, we take a look at the charge, and however many negatives you have, that's how many hydrogens you need. So simply, you add an H, and it becomes HC2H3O2. Even though that is a lot of elements, and it looks very complicated, it all comes from things that are already supplied to you. Next one, number 9. I see us. So us comes from ite. So this is from nitrite. Well, if we look at our sheet, or we talk about memorizing this, so nitrite must be NO. N is an odd number group, so it must be minus, and minus 1/8 are 3s, so this is an ite, so that's a 2. So simply, I need to add an H to that, HNO2, nitrous acid. Okay, so you will be using the X and the X and the us's to get you to ites and eights with your polyatomic ions. If you go to the right side here, we have 2 different problems, and this first one, because it's more than one element, we know that that is a polyatomic ion, so I looked that up, and that's phosphate, and 8 goes to ick, correct? So this is a little tricky. It's not phosphic acid, it's phosphoric acid. But there's the ick, because it came from 8. If that was phosphite, it would be phosphorus acid. And last example is when I see 2 elements, automatically I have to think hydro. So I say hydro, and then it's simply the element, and you drop the ending and add IDE. So that's iodine, so it becomes iotic, and then I add the word acid. So that's hydroiodic acid. It could be hydrochloric, it could be hydrobromic, or hydrofluoric. So those are some of our examples for our acid nomenclature. if we take a look at our other nomenclature, which is the stuff that we are going to be working on for the remainder of this chapter, now you have to make a decision. Is it ionic, is it covalent, or is it an acid? So you're going to use your help sheet quite a bit, but let's take a look at this. So let's do words to formulas first. I see carbon dioxide. The very fact that I see a di, a prefix, most likely tells me that it's covalent. So what is covalent? Covalent is prefixes. Right? These are prefixes. These are charges. It's a big deal. So I already see prefixes, but what does that mean? I do not crisscross. So I simply put a C, I put an O, and I put the 2 on where it's being told to me. The second one, number 5, I see no prefix. So I don't see any prefix. This is also a metal, so this is ionic. Now, you may not know what antimony is. Antimony is Sb. What charge is it? This 3 tells me it's 3 plus. I look up on the periodic table what F is. It's F minus. It simply crosses. So my final compound is SbF3, as an example. So that's how we're going to be doing some of that. And final set of examples is if we have to go from, this is a metal and a non-metal. So if that is the case, now it's prefixes. So this isn't phosphorus oxide, this is diphosphorus pentoxide. And if you have 2 vowels back to back, usually you get rid of the vowel that is on the prefix. Jumping down to number 37, because gold is a metal, that is going to be ionic. So no prefixes. So I'm going to say gold. Then every time I'm doing an ionic compound and I write a metal, I need to take a pause and ask, do I need a Roman numeral? Is it a transition metal? Gold definitely is a transition metal. We'll go back to that in a second. I say oxide. I'm running out of room here. And then now I need to use the last part. Now this has nothing to do with if it's ionic or covalent, but I have 8 waters, so I say, I'm going to just write it below slightly. Octa for 8, hydrate for water. Okay, so let's go back to the parenthesis. Is that the 2 or is that the 3? Is it how many gold I have, or is it the charge of the gold? Well, if you reverse cross, it'll tell you that it's a 3 charge. That's what it is. It's not how many you have, it's the charge of that metal. So hopefully that will help. Those are some examples of kinds of problems that we're going to be working on as we continue through nomenclature.